Welcome to Accelerated AI, where we simplify the intricacies of artificial intelligence. And today we are navigating through the fascinating landscape of generative AI. Generative AI, a pioneer in the realm of machine learning, generates unique, inventive data that mirrors patterns, styles, and structures from the input data it's been trained on. A cornerstone of generative AI is Generative Adversarial Networks, or GANs, introduced by Ian Goodfellow and his team in 2014. GANs consist of two parts: the generator, which creates new data instances, and the discriminator, which evaluates them for authenticity. And so these generator and discriminator components are both neural networks, a kind of machine learning model inspired by the human brain's interconnected neurons. They are trained simultaneously in a competitive setting, allowing the generator to improve at producing increasingly realistic data, and the discriminator to become better at distinguishing synthetic data from real data. Another technique used by generative AI is the Variational Autoencoder, VAE. Before we dive into VAEs, it's essential to understand what an encoder is. In the context of machine learning, an encoder is a neural network that learns to compress raw input data into a compact representation, discarding any unnecessary information while retaining the essential features. This process of converting complex input data into a smaller, more manageable form is known as encoding. Variational autoencoders take this concept a step further. They introduce a probabilistic layer that forces the encodings to follow a unit Gaussian distribution, a statistical profile representing average or typical data in a data set. This constraint leads to more diverse and creative outputs when the model generates new data. We also see the use of transformer models like the influential GPT-3, which employs self-supervised learning, is a learning paradigm where the data itself provides the necessary supervision. Generative AI applications are vast, spanning across numerous industries. It's used in healthcare for generating synthetic patient data to build robust models without violating patient privacy, in entertainment to create dynamic video game environments, in AI-generated art, and even in automotive design to help conceive new vehicle structures. Deep learning techniques, a subset of machine learning using multi-layered neural networks, form the bedrock of these generative models. This approach combines both unsupervised and supervised learning paradigms, learning from both labeled and unlabeled data, offering it a higher degree of adaptability and potential. Generative AI's power and potential reside in its capacity to learn and generate complex data distributions. As the architecture, computational resources, and training strategies continue to advance, so too do the possibilities for generative AI. Thank you for joining us on this exploratory journey into the future of AI with us here at Accelerated AI. And together, let's shape this frontier